Well, how are you doing? Okay, this is going to be a short video. Um, I have a lot of people who are on our opposing side trying to claim that when I'm showing what over 6R is, and I'm showing all the exact maths for that claimed, right, thing, right, and I'm showing moving diagrams to show the sizes of the effective radii, um, diameter and circumferences they need to claim. All these things I'm being told by our opposition now, because they're all denying their own model, which is absolutely not new, that I'm strawmanning them and I'm making it up, right? There's particular people who are saying this, and there's a lot of them saying it, but I'm not going to name names because I don't want to give any of these people credit. I don't want them to have anything to do with the video directly, okay? When you start naming names, it starts being focused on one person. But I'm being told that I'm strawmanning the globe and I'm not making the globe argument, blah blah blah. Right now, none of them can give me. I just, like, just give me the real answer then, and none of them can. Right? Because I can bring them straight to Metabunk, straight to their model, straight to Andrew Thomas Young. You know what I mean? San Diego State University. I can bring them to all that, show them exactly where their model is, you know, and how I am exactly 100 billion% right when I give them the maths and I give them the moving diagrams, right? None of them can prove me wrong because that's their model. They just don't like it. I've even had one of them make literally plead to me to start showing their model in a better light. They act like giving me suggestions on how I could let's just say detail and relay the maths to the audience in a nicer way. Why would I do that? That would be dishonest, and it wouldn't be what your model is. So they don't like their own model. I don't need your suggestions on how to make our model sound or look nice to the public. It's an abomination, right? A mathematical abomination is what it is. And I'm going to show here how I am not wrong, 100% correct. So I'm going to use the 31 mile distance and a 1 foot pure height. BLMSB 69. I went through this some weeks ago to show the amount of over 6R that the opposing side need to claim for this observation that BLMSB 69 did in 2021, I think it was, in Santa Barbara. So from 1 foot of observer height, I have it in a few videos back. I did a thing on it, and the video is linked in there. There's a 31 mile distance to the horizon, right? So let's just do the maths on that very quickly, right? So, right, so 31, right, by 31, you must square it, equals 961. Then you must multiply that by 2640, right, which gives you that. Then you divide by observer height, which is 1 foot. It won't make any difference here, but I just do it just to show I'm not skipping any steps, right? Gives you that, right? So your radius, their effective radius, they must claim for this observation by BLMSB 69 is 2,537,040, right? Miles, right? Miles, right? So if we want to find out how much over 6R is in that, we will divide it by their 3959 radius, right? 640, right? But then, right, what we must do is to find out how much over 6R, right, we must multiply that by 6. So multiply by 6 equals 3,844.9. So 3,845 over 6R. That's what they must claim. 3,845 over 6R. Metabunk only gives you 7 over 6R. 7. That's 3,845 over 6R. Metabunk give you an average of 7 because their horizon is always refracted. It has to be, right? Because in reality, the horizon never once in the history of the Earth has the horizon matched where our geometric globe horizon needs to be. So the horizon always has to be refracted within a model because the horizon has never, listen to that again, never, not even one time in history, and this is according to them, right? Not just us, them, has the horizon, right, adhered to the mathematics of their model. Not one time. Now, history is a long time. That's a lot of horizons that never, ever, ever adhere to their maths. So, which is actually flat Earth maths, because it's back engineered from flat Earth elevation angles to Polaris. But anyway, that's a side note for the moment. I'm going to show here how ridiculous their model is, right? This is an add-on to the 3845 over 6R, right? I'm just going to go to get that again, back to 31 by 31, right? Because I'm squaring it. 961. I know I could use the square function over here, but I want to go through all the things, right? Multiply by 2640, right? Give us that. Gives us that. Then I must divide by the height, which won't make any difference. It's only 1 foot, but I'll do it anyway, just not to skip a step, which is that, right? So that's their effective radius, right? 2,537,040. So if I multiply that by 12, right, to get the amount of feet, right, multiplied by 12 equals 30,444,480 feet, right? That's what it has to be, right? So that is the distance, right, within their effective, for their effective radii. That is what has to happen, right? Their effective radii, right? So they need to have an effective radii of 30,444,480 feet, right? So this is our curve calculator, MetaBunk, right? So let's come down here, right? So to get anywhere near what they need to have, right, as an effective radius, right? I come down here, as you can see, right? With the refraction approximation, giving it's not really refraction, it's just maths. It's not refraction. It's not as law around. It's not actual refraction. It's not like something that's real. It's just maths. Given an effective radius of 30,440,465.49 feet. So that's their radius, right? To get that radius, which is the closest I could get to matching this without going over this or too far under this. So it's pretty close. Right, so this is 30,444,480. That's 30,440,465. But it's close, right? But to even get close to what's necessary for them to claim this effective radius for that BLMS B69 observation, the temperature had to be 5.222, right? 2222 Fahrenheit, right? So that is minus 14.87 degrees Celsius. So that would mean that when BLMS B69 was taking the observation on that day, that it had to be almost minus 15 degrees Celsius, or 5.222 Fahrenheit, right? That's a very cold day. Minus 15, that is cold, right? That's a cold day, right? So it also, though, there needs to be a pressure in atmosphere of 9, right? Now, that means there's 9 atmospheres, right? Because I just show, right? Just going to come out slightly, right? So if I bring the atmosphere, right? I know it's a begging the question fallacy, but that's what they call them, atmospheres. Back to 1, right? Right, you'll have 4,872 miles of an effective radius, which is nowhere near what it needs to be. So I have to bring the atmospheres up to 9, right, to get the effective radius that's necessary, right? So 1 atmosphere is 14.6959, right? So you're talking basically sea level 14.7, right? So that's sea level 14.7. That's the highest pound per square inch air pressure there is. There isn't anything higher. I have never heard of higher pressure than that on average, right? Some places might go slightly higher, slightly lower, depending on elevation or depending on um, I don't know, the day, convection, different things like that. Yeah, that can happen. But as an average, 14.7 is 1 atmosphere, as they call it, right, within the units, the pressure units, right? So what's 9 atmospheres? 132.264 pounds per square inch. That would mean, right, that we'd have to have 130, let's say 132, 133 psi. 100, just to round it off, 133 psi. We'd need 133 psi to even match what is necessary for the globe. So it'd have to be minus 15 degrees Fahrenheit, Celsius, 5.222 whatever Fahrenheit, right? And we'd have to have 9 times our air pressure. The psi of water is between 40 and 60 psi, an average of 50, right? Of normal water pressure is generally 40 to 60 psi. That would mean that if we were in 9 times, 9 times our normal sea level pressure, we'd be floating around. You'd literally be floating. You wouldn't be able to keep your feet on the ground because you keep floating up to it. You would be floating up to it, right? So for them, the funny thing is for them to have for them to even claim what they would need to claim, showing here with their model, right? They would need to have 5.22 Fahrenheit temperature, which is minus 15 degrees Celsius, and they need to have a pressure on atmospheres of 9, which is 132. 133 degrees pounds per square inch. Sorry, not degrees, but pounds per psi, pounds per square inch. That's what they'd need to claim. So we'd be floating. We'd be floating around. So what would happen then with their gravity if they were claiming a force of gravity? So how would that keep us down? We'd be floating up to it. This is total nonsense. So I'm not making any of this up. There is your model. That's what it is. That's what you would have to claim. 9 times our normal PSI. I'm not lying. I'm not making it up. I'm not strawmanning anyone. Out curve, horizon bulge drop, and hidden calculator. Metabunk.org. That is your model. Not Brian's logic, your model. Thank you.